Hey everyone, welcome back to the Physics Unit 2 videos. In this video, we're going to specifically look at centripetal force. So just as we had discussed in our previous video, while mass doesn't affect your centripetal acceleration, it does affect your centripetal force. And so from Newton's second law, we know that the net force is produced by your mass times your net acceleration. So Newton's second law there says that it's your force is equal to your mass times acceleration. And we can replace this acceleration with the centripetal acceleration equation that we learned in the last video. And we get a simplified formula as F is equal to mv squared divided by r. And so just to note that with your mass, it must be in kilograms, your rotational speed must be in meters per second, and the radius must be in meters. So these are very specific units that we need to be working with. So if you aren't given those values, you need to convert them. So this is one example that I was leading up to in the video, saying that we need to have specific units, especially when we're working with meters and seconds. So anyway, so from here we can see that the factors that affect your force are your mass, your speed, and your that radius. And so they all affect it in different ways. With your mass and your speed, if any of those increase, you're going to increase your force, once again because you're increasing that numerator. But if you increase your radius in this case, it will decrease your force. So it's a little bit of a similar concept to what we talked about in the last video. So we're going to look at an example from your notes, and this is the first example from your centripetal force section. So here we're going to determine the magnitude of the centripetal force exerted by the rim of a dragster's wheel on a 45.0 kilogram tire. The tire has a 0.480 meter radius and is rotating at a speed of 30.0 meters per second. So as we like to in all of our examples, I'm going to start by writing down our information. So the first thing that we're given here is the mass of our dragster's wheel. So here we know it's a 45.0 kilogram tire. We know that it has a radius of 0.480 meters, and it's rotating at a speed of 30.0 meters per second. So as we should start to make a habit, we do want to check our units, and I was so nice to give you an example here where we don't have to do any conversions, because mass should be in kilograms, radius in meters, and your speed is in meters per second. So we don't have to do any conversions here, which means that we can actually jump straight to our equation. So to find that force, remember that's equal to your mass times your speed squared divided by that radius. And I guess one thing to note before we even go any further is that this squared only applies to the speed, not to your mass as well. If it was applied to your mass as well, you'd see brackets around here, so around these two variables, but you don't, which means that that square only applies to the speed. So returning to our example, we're going to start to plug in our values here. So we have our mass is 45.0 times it by our speed, which was 30.0 squared, divided by that radius of 0.480. So we'll do this step by step. So we're going to plug in our numerator first into our calculator. So we're going to go 45.0 times 30.0 squared. And make sure that when you're putting this in your calculator, the square only applies to this 30 and not multiplying these first. So be very careful with that. So when you put that into your calculator, you should get 40,500 as your answer. Then we're going to divide that by that radius of 0.480. I'm also going to keep track of sig figs here. So here we're just using our multiplying dividing rules. So we got 3 sig figs in 45.0 and 3 sig figs in 30.0. So then this numerator should also have 3 sig figs, making that 5 significant. So then we can go ahead and divide those two numbers. And in our calculator, we should get 84,375. And then to figure out the rounding for that question, here we've got 3 sig figs in our numerator, 3 sig figs in our denominator. So our answer should have 3 sig figs, making that 3 significant. Also keeping in mind that the 7 is going to round up the 3 to a 4. So our answer here is 84,400. Or if we want to put this into scientific notation, this would be 8.44 times 10 to the 4. And just like with our other examples that we've done in this course, with force, your units are newtons. So just to finalize this question, make sure we're going to answer this with a sentence, because it was technically a word problem. So we could say that the magnitude of the centripetal force is 8.44 times 10 to the 4 newtons. So now that you've answered this properly, you guys are all good to go. So if you guys have any questions, make sure to come see me in class, or you can text me on Remind 101. And thank you guys so much for watching.